Hi there, my name is Patrick Pusher, technical evangelist here at Orca Security, and it's my pleasure to spend about the next 20 or 25 minutes with you discussing how we manage risk in an ever-moving infrastructure as a service environment. So to sort of set the stage, we'll be talking about the history or the evolution of software development and infrastructure, how we've gotten here today. Then we'll talk about the security challenges with really modern agile infrastructure and the process or discipline of DevOps. We'll then talk about strategies to move fast and stay secure, where security doesn't become a roadblock kind of in your process, and we can really deliver on the promises of the cloud, right? The agility and the speed. Then we'll talk only for a few minutes about Orca Security, and then we'll wrap up with some Q&A time if we have time. And so if we just take a quick look at really the sort of evolution of how we develop applications, what the architecture of those applications look like, where those applications live, both immediately and then in terms of data center or cloud presence. We came from, if you're old like me and you're showing some gray here, and you've been in IT for that long, you'll remember the time when, we released software in these big monolithic packages. Even updates were sort of full product releases. They came, if we are lucky, every 2 or 3 years. Certainly a yearly cadence would have been unimaginable. Whereas, on the right-hand side of this illustration, we'll talk about almost an hourly cadence. We've come a long way. So, we certainly understood as applications grew and as we adopted, and began to think about things like as a service offerings, we knew that this application architecture would have to change. And so we adopted agile software development methodologies. We started working in much smaller chunks, and that was expressed in the architecture of our applications as well, right? So we had the clever idea of splitting out the tiers of our applications such that maybe patches or updates to one might not affect the other, or certainly we wouldn't have to re-release all of that software, if not, be able to keep applications running while we patch them. That's slightly probably a more modern convention than kind of that middle phase represents, but the foundation was there for that kind of application performance. And then at times we would choose to sort of outsource that data center presence into a hosted environment. That was kind of the start of the cloud revolution, right? Kind of coming to terms with the fact that, especially if we're not technology companies, why are we maintaining massive technology stacks when our focus is to create great widgets, for example? And so we often offshored or outsourced those to hosted data centers that were purpose built for that. And then if we think about where we are today, we've certainly gone, we still absolutely adopt those agile software development methodologies. We've gone farther in developing or combining rather software development and operations into kind of a single group or perspective that we call DevOps. When we mix security in there very specifically, sometimes we call it DevSecOps, but it's a discipline that is kind of this fuse of operations and development. And we'll talk about kind of where the dividing lines are and still exist today versus where they don't anymore. Moving from really sort of intelligently tiered applications to breaking them down even further into what we call microservices allowed us to keep an application running. If we did this the right way, keep it running and patch small discrete pieces of our application without even affecting kind of the rest of the application at large. That's squarely due to our architectural vision of microservices. Not a panacea, certainly. As we have more and more services, so too do we have more and more security controls to govern them, and we'll talk about that. But we moved from this notion of a physical server to a virtual server, right? Being able to say, okay, we have some spare CPU and memory and disk. Let's combine workloads. Let's virtualize a complete operating system and our application. And we even toyed a little bit in this era with shipping these as what we called virtual appliances. That was, especially at that time with the state of broadband, that was not as successful as we thought. But certainly now, as we think about that continuum from physical server to virtual server to now container, which is similar to a virtual server, but really only has the application and its dependencies inside it, not the operating system, right? We've certainly made it more agile from a DevOps perspective, from a developer serving themselves perspective. But now we have two vectors, right? We have containers to make sure we are managing risk in, and then we have the underlying operating systems that run them. Thankfully, the underlying operating systems that run them are far more basic than a full-fledged operating system. So from a vulnerability and risk perspective, they are smaller targets, but they're still, now there's sort of two sides we have to look at versus kind of one in the virtual machine era. And then, we do most of this certainly in the cloud, and especially as we think about continuous integration and continuous development, that is far easiest done in the public cloud, but not exclusive, right? There are certainly those that aim to practice this still in the data center, and we'll talk about that too. In fact, right now. So if we think about kind of a modern take on the data center, we'll typically have, applications that get developed, of course, IT infrastructure to run them. And then, if we're doing this in a modern way, we'll have a way to orchestrate containers, which is the way that these applications sort of get shipped, if you will, if not from testing into production environments. And so from a security perspective, we have concerns both, as I alluded to in the last slide, we have concerns both at that container level as well as the underlying virtual machines that run them. From a security perspective on the network, we have to make sure our network architecture, its segmentation, those perimeter firewalls in our network are maintained properly. And then, of course, our IT departments and our infrastructure teams also have to be very cognizant of the security of the orchestration engine itself, right? Kubernetes in this example. And so there's kind of these three vectors we have to think about in the data center in terms of a modern environment that's built to regularly compile and release software. As we think about that same example in the public cloud, we have some different concerns. Certainly, if we think about this attached to some sort of continuous integration, continuous development and deployment process, security very quickly, if you think about releasing not yearly, not even weekly, not even daily, maybe hourly. I certainly know at Orca, we practice very, very agile software development. We have the ability to release every day, multiple times a day if we have to. We don't often, but we can. And in that kind of case, security, manual security process, or even, semi-automatic security process stands in the way, right? And this is probably one of the key reasons that security gets left off the table more often than it should, is because it's hard, right? And if you're not, if you're going to insist on this manual gateway, everything is going to back up the promise of the cloud, of this whole kind of DevOps CI/CD process won't be realized. And so it's a problem. And then as we think about our networks in the public cloud, there's less to maintain from a big monolithic firewall perspective, but now thanks to microsegmentation, we have, many, many more times network security controls to keep an eye on, to establish and then to keep an eye on kind of in perpetuity than we did back in the data center, where we might have had a pair of firewalls or, several pairs for redundancy, but that's it. Thankfully, we get to really omit the security of the container orchestration engine, if you will. That becomes the responsibility of our cloud provider. So, a third of this sort of three-way model we get to drop in terms of what's our concern, thanks to that shared responsibility model of a public cloud provider. So that's great. But really, we do have these two deficiencies or big changes coming from our data center that we have to think about. One is, how do we get security built into this very automated CI/CD process such that it's not a bottleneck? And then second, how do we account for, the proliferation of security controls in our public cloud environment? Yes, they afford us much better security, much more granularity security, but from a management perspective, they become really challenging. There's many, many of them. And so if we think about that process, right, where developers code, they release, which typically involves, containerization of that application and its dependencies. It gets compared via policies that are established at that security operations kind of level, with some automatic tooling. And there's multiple ways to do this phase, right? We can express these containers, check them into a registry before we ever think about deployment, have a tool set that sort of looks at those containers and looks for software vulnerabilities and other kinds of risks, malware, hello SolarWinds for sure. And then depending on the outcome of that, pass it so that it's ready to be production tested and eventually kind of fully rolled out, or fail it and kind of loop it back into that process. There's kind of multiple ways of doing this, right? One can be, again, looking at that container registry, virtual machine image, rather than a virtual machine that's been provisioned. We can look at if your organization is mature enough to start to express, intent as infrastructure as code. We can look at that. But there are challenges in this phase, right? Because you're looking at distinct resources and you're not looking at the environment in which they will be pushed to, right? And it's both of those things. It's the discrete, what's in my container, what's in my VM, but it's also then in what context will it land? So infrastructure as code evaluation gets you a little farther down that line, but even there, you're only looking at, the delta of what you're about to provision and not what you're about to provision into. And so it's not perfect, but certainly, if we think about involving security, both in that, hey, let's evaluate what you've got before you even think about pushing it to production. And that can be in the way, again, of, multiple resources, in the way of infrastructure as code. So think of, Terraform or CloudFormation, or the actual content, right? And I should say and, not or. The actual content, what's inside your container, what's inside your VM images for risks. But then also, once we've evaluated that kind of pre-deployment, we can't keep our eyes off what that looks like in a production environment. And that may seem very standard, but there are some that think that if we do a good enough job kind of on the CI/CD side and we make everything immutable, meaning we never actually triage a problem in production, we always go back to our CI/CD cycle, we fix the problem in code, we destroy the resource in production, we push that newly fixed resource out instead of fixing something in place. There are those that think, really the balance of security has to be done on the left-hand side, and then once things are in production, because they can't change, we can have less of a rigor of a focus. And I think that's absolutely the wrong approach. I think you need both, right? Bad actors, as we found out with the SolarWinds compromise, can find their way into the left-hand side of this equation, right? Can find their way into injecting malware into your sort of CI/CD process. But the bulk of those happen, in production, where you've got a resource that is aged poorly. Somebody with malicious intent finds a way into your network, then looks to move laterally. So, rigor and focus has to be on both sides of these equations for sure. So a new challenge arises, right? This notion of continuous deployment and integration, it really does force this access control model that has to serve different audiences, right? We need a set of policies for what that CI/CD pipeline can do in terms of pushing to dev test, different ones in terms of pushing to production, right? And so we have a fairly sophisticated access control model that has to be established and then maintained. And then on the other side, you will have tool sets that, in a DevOps world, you're not sitting at the console kind of pushing buttons, you're integrating with APIs, and there is a access control model behind every API, right? And so right sizing that becomes really critical. And in the end, you'll find that you've got, very, very, or at least you should have very, very fine-grained, well-tuned access control policies, but you'll have several. And so we have, several competing interests for access, which makes this hard. And it becomes even harder when, traditional IT used to hold the keys to the castle with many disparate sort of authentication mechanisms, right? So you would have distinct credentials for your network routing core. You'd have distinct credentials for your storage filer, your NetApp appliance, for example. You'd have unique credentials for your hypervisor. And maybe you're doing some, single sign-on radius authentication. But for the most part, and especially for those admin root credentials, they're all different for each kind of service that you use in your data center. And if you compare that and contrast that to that, when you're leveraging especially a single infrastructure as service provider, there's one authentication mechanism that controls everything you do, right? So there is one, and we know from experience through all this sort of breach activity, we have a tendency to create more very privileged roles because it's easy, right, for those users that we trust to go in and administer our environments. But, we may have several. We always have one. We always have that root level, that you guard with your life. But too often we have many privileged roles, and if bad actors get their hands on the credentials, assigned to those roles and log in, they've got access to everything, right? Storage, networking, DNS. If you're a cloud DNS customer, which we know is really integral in terms of, malicious attacks. One set of credentials gives them access to everything if they're powerful enough. So, the fact that IAM is almost becoming sort of the new perimeter. It governs what we can do. It governs blast radius. It governs a lot of things. It's a challenge in it, and it's an area of hyper focus. So let's then talk about what are these strategies that we can leverage to do both, right? Move fast, gain the advantages of these processes and of this infrastructure, but not compromise on security. So the first one, and this is really critical, back in the data center, we would look at perimeter security, and then sometimes we would look at, host-based security, especially for our most sensitive workloads. Here we have another vector, right? Yes, absolutely. We have workload protection that is, without a perimeter, with just a bunch of sort of micro segmentation connected together. We absolutely have to be very diligent on the workload security, and workloads have changed. No longer is it a physical server or a VM, right? It's that, or it's a container, or it's a container as a service. And so we have a lot more flavors of workload, but we also have a new vector, and that is the cloud configuration, right? CSPM stands for Cloud Security Posture Manager, and it's a new category of security tool that we've seen debut in about the last 5 or 7 years, and it takes a look at all the services you use across all of the cloud providers you leverage, and make sure that the associated security controls with those stay consistent, right? And that can either look like your organizational preferences, or if you are more formally regulated, right? There are some standards to what these need to look like as they are. Think about, public S3 buckets that we read so much about. That is squarely the focus of a CSPM, making sure the security controls on that S3 bucket remain as you expect they do. But, we need a very purposeful look at both. And in fact, we need observations on the cloud side to inform our workload risks, and we need observations on the workload side to inform the risks we find on the cloud configuration side, right? It's not enough for a tool set or an approach to cover both. They really need these integrated, right? Because if I find something in a workload that's suspect, the very next question I'm going to have is, how exposed is it, right? And that's something I can't answer with just an observation of the workload alone. I need to understand the security controls above it in the cloud, the route tables, the security groups, what network it lives in, that sort of thing. So, and from a compliance standpoint, absolutely, you need both, right? There are mandates in every standard that require both. The good news is the cloud providers have done a relatively good job of interpreting those standards, and so have the third-party tool sets that sort of leverage those and go out and compare all these security settings to what they should be for any given standard. The second is to find those methods of measuring risk that are, painless or cause the least amount of friction organizationally wide, especially when an organization adopts the public cloud. They find, organizationally wide, they find these inter-organizational dependencies really challenging, right? Each business unit or project team has a different level of cloud and security maturity. They have different preferences on how they want to organize and triage this information. And so, having a method to do this that is very adoptable, that, especially doesn't require visiting each resource and installing agents or network scanners. That's the one thing that, we did in the data center. We couldn't get away from it. We started to develop tools that would sort of integrate at the hypervisor level through VMware, for example, so we didn't have to do per resource agent installation. But we didn't get that far. Right? In fact, we brought those practices over to the public cloud. And if you have to know about a resource first before you can install an agent to really understand any of the security implications or risks on that workload, you're already failing. Because again, if I'm a central kind of risk team for an organization and I've got 10 business units and project teams all using the cloud in a different way, getting that mandated that, hey, before you spin up any kind of project or application, you've got to follow these guidelines. It's already fraught with failure, right? So if you can find a way to do this without agents from a top-down way where I can install something across my clouds and get visibility, that's the way to do it. Make sure that the reporting styles are both kind of at that SOC practitioner level. I've got enough detail in there to fix things, but also I've got enough high level aggregated detail in my executive reports kind of for those stakeholders. And just, make sure that the alerts are risked appropriately. They have enough information to remediate. And again, as the last data point reminds us from the last slide, make sure you're looking at, CSPM kind of cloud risks, which are pretty easy to do agentless. It's kind of a more modern security vector, if you will. It's really workloads and data that is the hard part, right? Just about every way we have doing this, it is with workload agents and scanners, but a bit of a spoiler alert, that's what we do at Orca. So our third mitigation strategy is really, contain that blast radius. And the way we do that is twofold, right? We have to make sure that the access policies we assign to users and to resources, because they're not just for interactive users, resources also adopt access policies that dictate how much they can do and how much they can reach in their execution. Make sure they're right-sized, right? Let's not take any shortcuts and copy one massive overprivileged role for everything we do. Certainly we see that far too often. It's hard and time consuming to do this, but with the use of some helper tools, it's not quite as daunting as it used to be, and it'll pay off in spades, right? If we have, you don't even need malicious activity, right? If someone makes a mistake, you can see some of these policies are absolutely damning in the wrong hands, right? We've got the ability to delete DNS zones, to reroute traffic, to delete objects in S3 buckets, maliciously or honestly. These are devastating rights that if we don't need them should never be assigned to a user or a resource. But then also on the network, make sure that we're segmenting the network, make sure that we have these security controls that are now available to us in these modern cloud environments to segregate our applications from a tiered basis as far as we can. Sorry, number 4, build guardrails to enforce process automatically. We talked about this. If we are going to really take advantage of that promise of hyper agility and idea to revenue, right, in the public cloud, we have to find a way to build these guardrails, make sure security is part of the process, isn't a manual process that at the very end of all of this, right? Because that's the other side. If we go back to that CI/CD kind of diagram, if we invest all that time in terms of getting the application right, and then at the very end of that process, we fail from a security process, we have to go all the way back to that process, and we waste a huge amount of time. So processize your security. That way, we will ensure that we are preventing those software vulnerabilities that are remotely exploitable. We are preventing malware of any kind of getting injected into our code. We're preventing a lot of things, and we're doing so programmatically, and we're doing so really without really anyone having to pick up a security tool, run an application through a scanner by hand. It's just part of the process that developers kind of kick off and maintain themselves. Now, the last one, auto remediating is huge, right? I think it's where we're headed as an industry right now. Without a way to really customize and express conditions for your own environment inside of some of this tooling, we get a lot of false positives, right? And especially as in the early days of kind of machine learning and AI, are people doing things differently in your cloud environment than what I've seen before? If so, let me raise an alert. There are a lot of false positives, right? And so in the face of remediation, it's sort of the death of that effort, right? The last thing we want to do is to clobber a mission critical running application with auto remediation of a false positive, right? I mean, that's the quickest way to get that sort of capability thrown out of an IT department. So we're not quite there, but look for ways to customize the assumptions that your vendors have in the tooling around compliance and security, right? look for ways to, write a rule that says, hey, when I see a tagging standard like this, judge my infrastructure in a certain way. Or, if I find certain observations in the workload, make sure that I've got encryption standards turned on kind of at the cloud configuration plane, right? Until we can write really specific rules like that, auto remediation is a challenge because of all those false positives. And then lastly, when calculating risk, consider context. I alluded to this earlier, but if we adopt that CVSS score of a software vulnerability as the risk score of a particular alert, we're doing ourselves a disfavor, and not because it's the problem isn't important. It's just that if I find a software vulnerability that's remotely executable, that's got a CV score of 9, really high. But I find 2 of them in my environment. I find one that's publicly exploitable via the network controls that expose it to the outside, and then I find one in a workload that is hidden away from access from all others. Maybe except across a very kind of specific port. Maybe it's a special tier of an application, but it's not public facing at all. Should I care about both of those the same? Especially in the face of research that tells us that enterprise IT deals with anywhere from 10,000 to 1 million alerts a day. It's not that either of those observations aren't important. It's just using context, we can really start to separate what's actionable right now versus what's important and I need to keep an eye on, but that I can't do much about kind of, at the current time. And so that's the idea, is context is your best answer to reducing alert fatigue, because we know in public cloud environments that move fast, we get a ton of alerts. Let's make them meaningful and let's make them actionable. And so real quick, that's what we do at Orca Security. We've built a security platform purpose-built to support the big 3 public cloud providers. It is agentless. That's where that 100% coverage comes in, right? One quick-time kind of modern installation to your cloud. Orca can see your workloads, can what we call side scan them without any use of agents or scanners. It never misses a workload, right? It reads kind of from the top down. Every time you spin up a new instance or a VM, it knows about it. Also does the same kind of data scanning in storage buckets, looking for PII or malware, for example. So it really is kind of multiple tools in one. It's that CSPM, that Cloud Security Posture Manager, but it's also that a CWPP, that Cloud Workload Protection, among other things. And Orca's biggest pillar is that we use context, right? If we find a workload observation, we fill that data model with observations about what's above it in terms of networking. Not just that, context also means, is there a fix available for that software vulnerability that it just found, for example? We add up all that information, and that contributes to the risk score. So the alerts really matter. You still get the same CVE reporting you would expect from other tools, but you also get this very alert-centric, risk-centric view that takes your alert fatigue phenomenon way down. And then lastly, instant on, built-in compliance, many kind of best practices, but also if you're formally governed, we've got wide support for data security standards there as well. We're really proud of our work with customers. We've got double-digit sort of case studies. Orca's only just over 2 years old, right? So we're really proud of how many customers have gone on record for us. You can see them all at orca.security/reviews. And that's really it. I know that, in a very short amount of time, it's hard to cover that much material in detail. I hope that was useful, and we'll take any questions you've got now.